In 6.3, we're going to explore these sine and cosine and secant, all these six trig functions, dig into them a little bit more as functions, and we're going to get some tools that'll be really helpful to us throughout the rest of this course, and also into calculus, which is really what we're doing here. We're getting you ready for calculus. So before we start, I would like you to pause the video in a second, and I would like you to see if you can write out from memory the definitions of the six trig functions. So just write sine of t equals x or y or 1 over x or 1 over whatever it is. So see if you can write those six functions out, and see if you can also write out the first quadrant of the unit circle. So from 0 degrees around to 90 degrees, or to pi over 2, whichever measurement unit you're in. So pause the video for a second and see if you can write that out, and then come back. Okay, so hopefully you were able to write out the six trig functions like I've got here. And hopefully you were also able to do at least this first quadrant of the unit circle. So you should have gotten 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Or if you're in radians, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Along with the points. So you should have had 1 comma 0 for this point right here, then square root of 3 over 2 comma 1/2, square root of 2 over 2 comma square root of 2 over 2, 1/2 comma square root of 3 over 2, and 0, 1. And really, if you can do that first quadrant, you can do all 4 quadrants because they're all just symmetric. In any case, we'll keep practicing that. Keep in mind, those are the first 2 questions on the final exam. It's writing out these 6 trig functions, writing out a blank unit circle. Okay, so a couple of things I wanted to point out. One is an identity that we're going to make use of a lot. An identity just means an equation that's always true. So notice that sine is the y-coordinate and cosine is the x-coordinate. And the unit circle, the equation of it is x squared plus y squared equals 1, which means we could rewrite that equation and say x is the same thing as cosine. So really, cosine squared plus y is the same thing as sine plus sine squared will always equal 1, which means if you know the cosine of some angle, you should be able to use this equation to figure out the sine of that angle. You'll often see the book, and this is very common in all books, you'll often see them shorthanding this squared like this. They'll put it right there, which is kind of a funny place to put it. But they'll say cosine squared plus sine squared. And that still means exactly the same thing as this. It's just, like I said, they get tired of writing extra parentheses, so they put it in there. But it still means the entire cosine of t function squared and the entire sine of t function squared. Okay, so the next thing I wanted to point out is as you go around the unit circle, after you've gone a full 360 degrees, you start hitting the same xy coordinates again, which means you start getting the same sine and cosine and tangent values again. We talked about that a little bit in the last video, but to put some language onto that, that's what trig people will call the period of the trig function. And the period just says how long before values start repeating. So for sine and cosine and secant and cosecant, the period for all of those is 2 pi, or 360 degrees, which kind of makes sense. After you've gone around the circle once, you start picking up the same values again as you go around the second time. So after 2 pi or after 360, you start getting the same values again. Something a little bit different happens with tangent and cotangent. Keep in mind that tangent is defined to be y over x, and cotangent's just the flip of that, x over y. And I'd like to point out that tangent and cotangent start repeating each other even sooner than 2 pi. So look at, say, pi over 3 right here. The tangent of that would be square root of 3 over 2 over 1/2. And just look right across the unit circle down here at 4 pi over 3. The tangent of that would be the y over the x. It'd be negative square root of 3 over 2 over negative 1/2. And those negatives cancel, and you get the exact same value as you would have up here. And that's true for any 180 degree opposite, any values on the same spoke of the wheel. So tangent and cotangent actually have a period not of 2 pi, but of pi. So let's put that down here. We've got tangent and cotangent. Their period equals pi, or 180 degrees. So they start repeating themselves sooner. Okay, so last thing I wanted to point out, at least on this piece of paper, is since these other 4 trig functions are all defined in terms of x and y, which are just nicknames for sine and cosine, we can write them all in terms of sine and cosine. So for instance, secant of t is 1 over x, it's also known as 1 over cosine. So secant could be rewritten as 1 over cosine of t. And cosecant in the same way could be rewritten as 1 over sine of t. I did not use very good paper space management here, but tangent could be written as sine over cosine. I'm not going to try to jam that in here. And same thing with cotangent. It could be written as cosine over sine. So all 4 of these can be written in terms of just sines and cosines. And that'll be really helpful to us later when we're trying to solve equations and we don't want 6 different trig functions floating around. If we can get it back to just 2 or even 1 trig function, that'd be even better. Okay, so I am going to, in the examples, talk a little bit more about even and odd functions and domain and range, which are all sort of classic characteristics of functions. And that's, since we're trying to deal with these things as trig functions, we'll look at those in the examples.